So don't worry, for this part you don't really need to have your computer open unless you're taking notes or whatever, so you won't be doing work, and you have access to all of the slides after I'll send you the slides at like lunchtime, so you don't need to make like notes of what I'm saying. You'll have access to everything, but if you want to keep notes for your own understanding or whatever, then please do. Does that make sense? So yeah, I'll send you the slides after the thing. So don't worry about writing everything down. Okay, great. So do you guys want to bring your table closer? Because I think if we set it up now, then no one will. Yeah, maybe move this one in further. So there's like one space here as well. Somebody wants to come a bit closer. Tony, sorry, can you find the whiteboard markers? Oh, okay, that looks good, yeah. That looks good, we can sort, and then if it doesn't work, we can sort it out later. Okay, great, thank you all. So, yeah, this is the slightly more advanced stream, and yeah, like just to build on what George was saying earlier, this is very much not a kind of lead you by the hand course at all. Normally when we do like very beginner training courses like Introduction to Bioinformatics, we have to write all the resources, and every letter has to be correct. It can't be capitalized when we mean lowercase. It can't have a space when we mean a tab. Everything has to be perfect, because when beginners, all of those things can trip them up. So the idea is that these situations that you're going to be getting, the exercises, are much closer to what you will get in reality. In reality, if your boss asks you to do something, they're not going to give you a step-by-step guide of like a step-by-step guide of everything that you need to, every stage you need to go through. They're going to say, can you do this can you solve this broad problem for me? And then you have to solve it, right? So that's much more the structure of what we're doing. It's the first time I've taught a course like this, so I'm very open to feedback. If you think something isn't working, or obviously you're here to learn, so I'm here to help. Absolutely. So please don't struggle, by yourself for too long. But that's just the general philosophy of the course, is that this is trying to replicate how you are going to be acting in your institutions back home. Okay, so advanced Python. So just to briefly go over the prerequisites, I think I said this already earlier. So you should be very familiar with like the standard Python data structures, list dictionaries and everything. So you should be familiar with dictionaries within dictionaries within dictionaries. So we're going to do, that's one of our training exercises. We'll do that as well as the classes to kind of compare and contrast the two methods. And you should use functions in most of the scripts that you write. So is that kind of, everyone's very familiar with functions? And yeah, great. So, and absolutely, if if after this session you feel like it's not for you, then you can switch to the other stream, no problem. Okay, so who's heard of the Dunning-Kruger effect? The internet is a big fan of this, right? So the Dunning-Kruger effect is there are a couple of psychologists in the late 80s, early 90s, I think. They came up with this idea that the kind of relationship between your confidence in your ability and your actual ability is not linear. So you don't learn a bit, gain confidence, learn a bit, gain confidence. What happens is that as you start to know a bit, as you gain in wisdom or skill or experience, your confidence shoots up, and you're like, yes, I can do everything. I can, I'm a master coder. I can solve any problem. Bring it on. And this is what they call the peak of Mount overconfidence. You're very confident, and then what happens is you start to learn a bit more. Is that you realize how hard coding is, how difficult it is to write bug-free code, and even the best software engineers in the world say the only way to have a bug-free code is to have zero code, right? That's the only thing that's guaranteed to have no bugs in. And as you kind of realize this and how difficult it is, your confidence shoots down, even though your knowledge is going up. So your confidence comes down, and you enter the valley of despair. And you think, oh, it's awful, it's so hard. I can't do it. It's like, why is everything so bad? But then as if you persist and you keep working at it and you keep gaining in the skill, then you begin to go up the slope of enlightenment. When you have kind of, you're highly skilled, or you're gaining skill a lot, and your confidence is growing as well. So I would say that after 10 years of coding, I'm like somewhere kind of between the slope of enlightenment and the plateau of sustainability. Definitely I recognize this is kind of, it's a schematic, right? It's not a kind of hard and fast truth. But I think that this is quite a model that a lot of people go through when they're acquiring any new skill, and coding in particular. So is anyone going to be brave and say where they think they are on this plot? So the idea is that you kind of should all have gone through the valley of despair, because the tools that we're going to teach on this part, they're going to help you to write better code. And they're slightly more advanced. So they're kind of, the goal is that by the end of the week, you should be heading up the slope of enlightenment. Anyone going to be brave and say where they think they are? Well, it's the honest answer, yeah.
Just picking up from despair.
Good, nice. That's what we want. Anyone think they're on the plateau of sustainability? Okay, good. Because because all that is saying is what your confidence level is, right? You've said what your confidence. You haven't said anything really about your true wisdom, your true skill. So if anyone had said that they're on the plateau of sustainability, we would all have to judge for ourselves whether we think that they're here or there. So, yeah. But basically, the idea is, let's get ourselves out of the valley of despair. So we're going to do two things in this course. We're going to do custom classes. So this is a kind of object-oriented programming. So Python is a very flexible language, but we can use it for object-oriented programming. So that's what we're going to learn today and tomorrow. And then I think maybe tomorrow afternoon we will start with exploring a bioinformatics module, BioPython. And so it's not so much exactly like learning about the functionality of BioPython, it's about how do I take an external library and get to grips with it, because they're not easy things to get to grips with, and they're a really good crutch, they're a really good tool that you can use to write better code. And then, sorry, there should be one more here of kind of best practices. So then we've got a bunch of best practices for the last day, depending how much time we have. I think there's 6 or 7 best practices to go through as well. So hopefully we'll have time to do at least some of those. Okay, custom classes. So we're going to have like a motivating example, like why do you want to do this? And honestly, this is like the reason that I wanted to teach this advanced Python module on this course, is because once you learn how to use classes, it's so liberating in your code. It's just kind of, it gets rid of so much complexity. You can do so much more. And yeah, for me anyway, that was the feeling after I had finally, the learning curve is not even that steep. It's just a little bit of a bump. And then it's a really powerful tool for organizing your code. So does anyone write their own classes already in Python? Okay, good. So everyone will learn something. So we're going to have a motivating example. And basically, we're going to start with something very simple. And it's going to get more and more complex until it's kind of too complex for like not use classes. And technically, obviously, you don't have to use them. It is physically possible to use it to do the approach that I'm going to lay out to start with. But then once we get to that level of complexity, that's when classes start to become useful. So we're just going to start with a list of scientists. So we have Charles Darwin, George Washington Carver, who was a botanist in the US. Margaret Dayhoff, who's like a very early bioinformatician. She came up with lots of the amino acid substitution, scoring matrices, and then Marie Sklodowska-Curie. So we want to, we're doing a project and we want to keep some information about these scientists. So first of all, okay, we just start with a list of names. That's not very helpful. And then we decide, right, we want to start keeping some information about these people. So what's like the natural data structure when we have like a name and we have some information about the person? What's like the right data structure to use? Dictionary, yeah. So which is what we have here. Now the name of the scientist is the key, and the date of birth in ISO format is the value. So now a scientist is a dictionary where the name is the key and the date of birth is the value. So what's this code going to return? What's this going to output? The print scientist Charles Darwin there.
1809-02-100.
Yeah, it's going to output this. So scientist is a dictionary, Charles Darwin is the key we're giving, and then it's going to return the value there. Okay, everyone comfortable? Okay, so now we decide we don't just want to keep the date of birth, we also want to keep the place of birth. And so, we could, there's like a couple of different ways you could do this. You could have the values be lists. So maybe it's a little bit clearer. So we could, change this into a list where the first element is the date of birth, the second element is the place of birth. So that's one way we could do it. But then sometimes lists, aren't the right data structure. If there's a flexibility in the data that you're storing, like you don't have the values for some of them, the list might not be long enough. You want the second element, that list only has one element, and you get a lookup error or an index error. So we decide to use dictionaries as the value. So this kind of can be a little bit of a moment when people start to be kind of choking a little bit, but dictionaries as values, is that something that people are familiar with? The practical exercise, you'll get to grips with it anyway. So if it's not super intuitive right now, then by the end of the day, hopefully it will be. So now we have dictionaries within dictionaries. So the overall dictionary is called scientists, And then the keys in that dictionary are still the names of the scientists, but now the values, rather than being a single string, is another dictionary. And each of the dictionaries has two keys in, the same keys. We have date of birth and place of birth, POB, place of birth. So now, can someone say what this code is going to return? So what's going to be printed? Sorry, I can't hear. Yes. Yes. Yeah, exactly. So this is the key. So now, in the same way that on the previous slide, when we did this, we returned the value. So that's the value that we're returning. Now, when we do this part, what's returned is this dictionary. So that is equal to this dictionary. Okay, so then so this is a dictionary, so when we use this key, it's looking up this one. Okay, so that's the syntax there. That you have this is the dictionary, and then this is the lookup on that dictionary. Okay, is that clear to everybody? Okay, so what if we want some more information about the place of birth? So we don't just want the country of birth, we want the city and the country. So one solution to this would be to have another layer of dictionaries. So again, so we have the overall dictionary, which is scientists, where the keys are the names of the scientists, blah, 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 blah. And then the value of that is a dictionary that has two entries, date of birth and place of birth. And the value associated with date of birth is still just a string, still just the date. Whereas the value associated with with POB within this second level of dictionaries is now another dictionary. And there we have the city and the country of birth. So we have city as Shrewsbury, country as UK. And so similar for all of the other scientists. So now, again, this dictionary, scientist Charles Darwin, is this second dictionary with the keys place of birth and date of birth. So then we access this value. So that value, the value associated with this key, is another dictionary. So, and then this is a valid key within that dictionary. So I think, it's quite obvious what is going to be printed now. UK, yeah. So, this is all perfectly valid code, runs without error, etc. But I think, what's your kind of take on this code? It's okay, it's kind of, yeah.
Next step.
Yeah, it's kind of a training. It's like a toy example, right? To illustrate the point. But it's highly nested. It's quite complex. You can imagine it being this isn't really how we would ever enter data into a Python program, right? You don't manually specify the variables. You read them in from a CSV or whatever, and you set it up yourself. So it's kind of hard to get to grips. It starts to get really complicated, right? Which are the layers within the dictionary, all the way down. It's unwieldy, I would say. Yeah. So So the idea is that whenever you start to get somewhere like this, whenever you start to get with really layers of dictionaries, or even layers of any kind of data structure, very deeply nested, then it's a good idea that's when you should think classes. That's the kind of problem that classes are going to help you with. Okay, sorry, and we go another layer, but it's kind of just more of the same. Okay, so then what happens if the population of the USA changes? Okay, sorry, we're going to just do this quickly. So now we add another layer of dictionaries where the place of birth is represented in a dictionary, or the value of the place of birth key is now a dictionary, where the first value is a city, which just has a string. The second value is country, that has another dictionary, which has a name and the population. So now the population, we have 2 people who are born in the USA, and now the population of those different countries is there. So what happens if we want to change? What happens if our data set changes and the population of the USA is now different? What do we have to do? Yeah, you have to change both of them, right? You have to remember that both, we have 2 instances of this USA kind of country, and if we want to, our code to be valid, then we have to update them both. So we have to say, okay, we have a new population for the USA, 331,900,001 now, and we have to say, okay, inside this dictionary, within George Washington Carver, his place of birth, which is a country, and the population is now this, and same for Margaret Dayhoff, all the way down. So that's very clunky as well. Okay, so what's the alternative to this? The alternative is classes. So classes are fundamental to a kind of paradigm of programming, kind of a way of programming called object-oriented programming, which is very popular, very common, in software engineering. And basically, the kind of fundamental idea is that it bundles variables and methods together into objects. So you combine methods and variables for a particular type of object into a single class of objects. So, and that's a blueprint. The class definition is just a blueprint for the object. It doesn't contain any data in the same way that, when you define a function, it doesn't do anything, right, until you run it with some input data. And the class is the same, so you have a class and then you make what you call an instance of that class. So the class is like the blueprint, and then you instantiate an object from the class. You make an instance. Instantiate means like make an instance of it. And then you make a new instance of the object, and that's not the blueprint anymore. It's a real thing. It's an instance. So instance and object, these are like key pieces of vocabulary. And that contains some kind of data, or is like a specific instance of the object. So kind of just coming back to this second point, so classes are a way that you can combine data with methods to work on that data in a single object. So not only can you have variables, you can also have what's called in like object-oriented programming, which I'm going to refer to as OOP. In an OOP paradigm, that's called encapsulation, and you have so in OOP they sometimes refer to functions as methods. So an object can have methods associated with it that obviously typically work on data, on variables belonging to that object. So you combine these 2 things together, and it's like whenever you have like some data belonging to that object, you have the methods to work on that object, on that data as well. So it's very convenient. Okay, so this is like the. All right, any questions so far? Or what questions do you have? Nothing? Okay. So this is just some of the vocab. So this is in Python how just the syntax for defining a class. So keyword class, then the name of the class, which is going to be scientist in our case. And then we have typically you have this first method. So this is a method. We're defining this new method here. Sorry, can you see? Okay. We're defining this new method here, and it has this special keyword underscore underscore init underscore underscore. So that's a kind of special method that is almost always the first method in a class. And this is run when a new instance of the class is made. And so it takes this one takes 3 variables, but this always takes this self variable. So this is like the tricky thing about classes, that you kind of just need to let wash over you a little bit and move on and kind of use it. You know, you just need to like don't like obsess too much about this. It's not straightforward exactly what is happening here, but basically self just means like the class itself. So it's kind of weirdly self-referential in that you're like passing it to itself, but it's kind of just when you make an instance of this object, self is like that particular instance. So then when we assign these variables to self, they become class attributes or object attributes. So they're special kinds of attribute that we can access, like in outside of this scope. So does that? Yeah, you're kind of familiar with scope, right? So like normally, if we didn't have these things, if it was just name equals name, then when we get to the end of this function and we quit, we kind of move back to the code that called the function, then these objects would be garbage collected, right? In Python, we don't pass variables like this way in the scope unless you specifically return. So if you wanted like name out of this function, then you have to return name, date of birth, place of birth. But the kind of big thing about classes, or one of the big things about classes, is that they have what's called state. So we have this self, which is like the class itself, and then whenever we say self.name, we don't need to return. We don't need to return those things from this function. We don't need to pass them around. They just become attributes of that class, which is really, really useful, really, really powerful. Because rather than returning things, we just kind of everything can be much cleaner. So we're setting these variables to be name, date of birth, and place of birth. So this one's a little bit different. So here, so this is coming in. These two are coming in from the definition, and so this is now. So anyone going to be brave and tell me what in the terminology that we've been talking about so far this morning, what is this now? If this is an object, what's this? Yeah, great. It's an instance. Yeah, so that's an instance of the object. So it's kind of we've run this. You can think of it as like a function, like because and has brackets here, so it's kind of like a function, and it's just a function to make a new object of the scientist class. So now this is an instance. So when we do this, this is the function that's like actually kind of running. So we don't pass self. So here we don't pass the self argument, anything like that. That's just kind of, it comes from, I think, here. But we do pass these two other variables, so those go into name and date of birth. So we kind of, when we make a new instance, we you kind of, if there was only self, this would have nothing in. And that would be fine. We're just going to make a new object, and maybe we'll do some other stuff to it, use some functions or whatever. But it's quite typical to give some initial data when you make a new instance of a class. So then it comes in here, and then gets assigned to self.name. The name gets assigned to self.name, and the date of birth gets assigned to the date of birth. Okay, so don't worry if that didn't make loads of sense. That's what the practical exercises are for. So this last one is a little bit trickier. So we have this place of birth class attribute is, we're going to set it to be this place of birth. But that doesn't actually, we're not passing that in right now. So there's like a couple of different ways you could do this. So one of the big things about using classes is that it's a way for you to think about, how am I organizing the different types of object in my script. It's like, it's just a tool for you to like hang things on. It's like, okay, I'm going to make a new scientist. Like, what are the attributes of it? It's like, what are the attributes of a scientist going to be? What kind of methods do I need to like work with my scientist class? So before you kind of get too deep into the code, you should think about what kind of attributes they're going to have. What belongs to the scientist, what belongs to, if we had another class that was like research lab or whatever, what attributes would belong to a research lab. It's kind of, really thinking about how the different objects that you're representing in your code relate to each other. And so this is a kind of, so it's typical to have all of your class attributes defined here, even if you're not taking them in on initialization. So here we're not taking this in on initialization. When we instantiate a new instance, we're not accepting place of birth, but we're just telling the class to expect an instance of the place of birth class. So sorry, I should have said that the norm is classes have start with an uppercase, and personally I use camel case. I think that's the norm as well. So camel case, where the start of each new word is a uppercase letter. So we're telling it that this is going to be a place of birth class. So that, and then if we had another thing like, I don't know, nationality, self.nationality, and we were going to do that later, we could just put none equals none. And it's just like saying, when we set up, this is going to be an attribute of scientist. You're just organizing your code and telling it that you have certain expectations. So you could just put none, or you could just put str, telling it that you're going to just plain str, telling it you're going to give it a string. And then later on, you could use a test to say, checking when you do set that instance, is it the kind of attribute that is it the kind of variable that I'm expecting it to be? But that's kind of later on. So this will have to have been defined like above this scientist. So we're going to, in reality, we have another class here that's the place of birth class. Yeah. Okay, so fairly straightforward again. So what's this? What are these two lines of code going to do? What are they going to output? Charles Darwin and... Yeah, they're just going to... Okay, so this is how we access these variables. Darwin is the instance of our scientist class, and then we use this and then instances are usually lowercase, and then we use this notation, just the dot notation, to access the class attributes or the class instances. So this is like you've done this so many times, right, in your Python code. Like whenever you like if you use like the split function, then can anyone tell me how you use the split function? So you have you've got some so if we wanted to split Charles Darwin on spaces, so what would the syntax be? What would the line of code be? Speak up if you know the answer.
Charles Darwin dot split, then the separate split.
Yeah, exactly. And so so you have this Charles Darwin string dot split brackets and then a space in quotation marks, and that's the same kind of thing that's going on here. This dot nomenclature. So you have a string. So in the example, sorry, uso.
Also, yes.
Also, so we have the string and then the dot split. So the dot split is a function of the string class. So Python knows that this is a string. Strings are objects, they're classes, and they have a bunch of functions and a bunch of properties. And one of those functions that's defined in the Python source code is split. So we say dot split, and exactly the same thing that's kind of going on here. So it will just be a different function saying what to do when that particular thing's called. And one of the arguments that function takes is whatever you want to split on. So you're very familiar already with this dot thing. You've used it lots of times. Now you're just doing it on something that you've defined. Okay, so obviously you don't need to limit yourself to just a single class. So now we're going to kind of do the same. We're going to step through the same example, but in an OOP way. And I mean, this is like the minimal. This might seem like as complicated as the other way, or maybe even more complicated because you're not used to it. But it's kind of just a minimal working example of like how to do it in two different ways. And so hopefully once you get to grips with it, you'll realize that it's much simpler. But in anything like in coding, you have to decide whether or not it's worth the investment of kind of setting up the classes and everything, or just doing it in the kind of typical way with dictionaries and what have you. So, that's something you have to think about. Typically if it's like, just a kind of fairly simple script with, less than 100 lines, I probably won't use classes unless there's something particularly funny going on. But once you get to more complex applications, then that's when when classes come into their own. And so that's a little bit difficult to teach on a course like this because, even when you know what you're doing, it could take you like 2 or 3 days to like write one of those applications, right? So we had to have teaching examples that are a little bit, that the full benefit of classes doesn't quite come through, but hopefully in the exercise it will somewhat. But just to kind of so you are aware of, that's just a little disclaimer that this is something that you use for more complex things, and what we're doing here is not necessarily like that complicated. So we have these different classes defined. So scientists we're already familiar with. Place of birth is a city. And then it has this attribute variable, which is city, which comes from when it's instantiated here. Scientist we've already done, but now place of birth we know is going to be an instance of this class, so that code runs fine. And then we have a city class, where we have the name of the city and the country that the city is in. So then again we assign them to these class attributes. And then finally country, and the country is another class that has the name and the population taken, name of the country and the population of the country taken in from when the class is initialized. So you can see that this kind of duplicates the dictionaries at each of the different levels, previously, right? So we had like the overall thing was scientists, and so that's like the highest level within that first dictionary is the scientist class, and then that has some information. Then one of those is a place of birth. So the place of birth is an instance of the city class. So this is slightly. I just did this to kind of follow through with the dictionary structure. This is slightly kind of duplicated. You could probably do with. You probably don't need this class. You could just have city. But I just wanted to follow through with match the dictionary quite closely. And then country as well for that for the country level information. And so just a couple of things. So put your hand up if you don't use asserts. This assert statement. So put your hand up if you don't use asserts in your code. Okay, so lots of you do use asserts. Okay, good. So asserts are really, really useful for those of you who don't use them. They're just like a super simple test. They just say, and they're very useful in lots of different circumstances, but you can assert, what we're doing here is asserting that this lowercase country that's coming in is an instance of the country class. So we're just checking that, we haven't accidentally passed a list or a dictionary or a string as this country argument. So that we're asserting, and then if it's not, we fail if the code exits with an assertion error. So this is a really good idea to start using in your code. It's just like super simple tests, like assert that this list is the same length as that. If you have a header list and a content list, then that's a really common time when I will say assert that the header is the same length as the content. Because sometimes you add more things to the content, you forget to add something to the header, that kind of thing. So assert's very, very useful. And then we've got a couple of those. Okay, so these are the classes themselves. They don't have any data in. They're the blueprints. And then over here we have the actual instantiation of these objects. So we have 4 scientist objects, 1 for each of the scientists with that information. We have 3 country objects. So perhaps you might think, we've only got 3 country objects now, but we've got 4 scientists, and that's because 2 of them are from the same country. So we've already got a USA country instance. We don't make another one, right? And this is because in reality there's only one USA, right? So we don't need another one. So this is like part of where classes start to become really powerful. And then there's 4 cities, and then these take in country. So Shrewsbury, the second argument for the city, goes to this country. And country has to be an instance of the country class. So this is this. So it's an instance of the country class, it's an instance of the country class. And so, you see that these 2 are the same. So these 2 have the same instance of that class assigned as their country because they come from the same country. And then same place of birth has to be a city. So we're passing Shrewsbury city instance in as the place of birth argument. And we're assigning it to, because remember that this one, it doesn't happen when we set it up. We don't get place of birth when we instantiate the object. So we need to assign it now. And so this is the syntax, the notation for that. So we just Darwin, which is our instance of the scientist object, dot place of birth, that's the attribute, equals the place of birth. Okay. And so now, if we want to do like the kind of same kind of thing that we were doing with like the keys, with all of the dictionary keys, then this is how we do it. So with that dot notation, so Darwin, dot place of birth, dot city, dot name. So I think this is useful in a couple of ways. I mean, you know, if you're picking your key names well in your dictionary approach, then it can also be like fairly easy to do. But you know, if you forget what the attributes are, you can just look at the class definitions. Also, many coding, many even like Sublime Text, and definitely the more complicated IDE integrated development environments like Visual Studio or whatever, they will like they'll introspect your code, and they will know that this is a instance of the scientist class, and the scientist objects have this place of birth attribute. So if you just type here Darwin dot, it will come up with these different attributes, and you can just select like which one you want. It like so it makes it much easier to autocomplete. And then same when we've done that, and we say dot, it's like, oh, that's a place of birth instance. So what attributes the places of birth have? Okay, they have this. So therefore, so this all autocompletes, and it makes your code much smoother and easier to write. You don't have to be like, oh, what was that dictionary called? What was that key called? And when you haven't had that artificial situation of specifying the dictionary like exactly, you know, writing it all out, then you know that can be very useful. Okay, so I think that the answers to these are quite obvious. That it will just be the city name for Darwin and the country name for Darwin. So Shrewsbury and UK. Okay, so finally, or getting towards the end, so classes have as state, as we've spoken about briefly. So state just means that once you've created an object and you've added some data to it, the data will persist as long as the object is alive. So we don't have to worry about returning things. So previously, when we wanted to update the population of the USA, this is the way that we had to do it, right? We had to, you know, have all of these keys, and we had to do it twice because those two objects were different objects. Whereas now, what all we have to do is, so here, the population of the USA, these two first print lines will be 331,900,000. That's it. And then all we have to do is update a single instance of the class, because both of these have this single instance of the class as their country, as the country in their that's attached to their city, that's attached to the place of birth, that's attached to the scientist. So all we have to do is update that one thing, and then these two will both now be this. So that's very, very useful as well. Okay, so in summary, classes let you simplify your code, and because they take care of, they're just a good way to organize your code basically, and you know, when something's simpler to do, and when something's more organized, you can do more complex things basically. So that's the idea, is that you can do more complex things. They provide a kind of meaningful objects. You know, if you think about it carefully and you design your classes well, then they should represent, you know, real things that have lots of values and attributes those real things should have, or you know, do functions that you want to do on that kind of thing. So they're kind of quite semantic. They have meaning, and they're like, and human brains like to, you know, work with things that, you know, kind of have some real world meaning. And then they have state and the attribute objects the object attributes will persist without being passed around through lots and lots of return functions. Okay, so yeah. Thoughts so far? Anyone?
I had a question in that complex slide. Just go back. Yeah,
This one.
so the place of birth class, you have the class city there, right?
Yeah.
But then you've defined the class itself a couple of lines down there.
Sorry, come points.
So it's this bit. So it's passing an instance of the city class. And then you have it.
Yeah.
Some other in the game.
Yeah, with that, I think that would run.
So you
Sure.
drill.
Yeah, good point though. Maybe it wouldn't. I think it would though.
Run.
As long as it's in the same.
Then you like a
Indentation.
As long as it's in the same piece of script or code. For classes, it doesn't matter whether you define before or after.
Maybe, but I'm pretty sure when I did this, when I had the place of birth below the scientist, it bombed out. Okay, well we can test it when we're upstairs. Yeah, that's your job, Mike. Sorry, Mike, right?
Yeah.
Yeah. So yeah, we can test it. Anything else?
Just a question with this, out of this. So my question would be, you sort of can also you define a dot string for the class itself?
Yeah. I don't use them myself. Does it come in under here?
Yeah.
I think it comes in there, like below there, right? Yeah, in this. They're called like class attributes. Huh?
I think PyCharm has that functionality.
Yeah.
Yeah.
When you just write class, it will come up with like the template for it. So yeah, those are like class attributes that are shared by every instance of the class. Like they're common to everything. So I don't use them very much myself, but that's where they go. If it doesn't vary between different instances of a class, then you define it like in between, like there, I think.
There is an aspect of inheriting the base class.
Yeah.
How do you know whatever you want is inside your class is contained within the base class? Is there a way of
So that's like we'll do that at the end. Yeah, I didn't want to get into inheritance in the first talk. Yeah, but yeah, basically, yeah. But we can talk about we can talk about that in the practical, or and we'll mention it later.
I'm a bit confused with the class place of birth.
Yeah.
You declare first, then you put it as a
Yeah.
you put it as an attribute.
Yeah.
So why you did that? Why?
Why did I do that?
Yeah.
So nothing bad would happen if this was just none. If I just put none, and in fact, nothing bad would happen if I didn't even. If this line was not here, nothing like the code wouldn't error. I think most things like PyCharm would give a warning saying when you run this, it would say like class attribute not defined in like the init, which that's like a good coding practice to do that. So nothing bad would happen if we didn't do this, because you can just do this without this already existing as a variable, as a class variable. But it's just a good practice to have to think about all of the different attributes your class is going to have. And then it's also a good practice to say what you're expecting them to be. So if you're expecting it to be a string, you just put str, no brackets. And that's just the string class itself, rather than an instance of the string class. And in the same way, this is just saying it's going to be place of birth class. It's not a place of birth. It's not an instance of the object. It's the object itself. It's a blueprint. It's not the real building. It's not the real thing. It's like the plans for the thing. And so that's just, yeah, it's just like a good practice to say that's what we're expecting this to be.
The way you access it.
Yeah.
Like there's that Windows, but it's different from the other one. The way you define the city.
Yeah.
Confusing like.
So you mean when we're assigning them here,
Yeah.
here and here?
Yeah. When you assign
Yeah.
like,
So because it's to do with whether or not, so this is the function that's run. So let's say city. So this is the in underscore underscore init underscore underscore is the function that is run when we do this code, city brackets. Okay, so that's the function that's run, and that function expects two arguments, name and country. So name and country, and then those go into these object attributes, name and country. So that's how that one works, and then place of, but for the scientist dot place of birth. So scientist dot place of birth, it doesn't come in here. It doesn't come in up here when we make the new instance. Okay, because there's no place of birth here, right?
Yeah.
So it's not coming in at the beginning. So we put it in later. So it's like, it's like leaving a little holder, there to put it in at a later date. And then that's what we're doing here. We're just saying that we're going to put that in now.
And the set function, the function is for checking like, is it true? It's for checking the availability of it, or
It's checking that. So this is saying assert. Okay, so I'll just assert that country is instance of country. So assert that this, whatever's coming in as this second argument into the function, which is here when we call it, assert that this thing is an instance of the country class. So that uppercase is how you know it's the class itself and not an instance of the class. So yeah, it's just saying, so if rather than UK like this, you put string around it, then this assert would fail, because then this wouldn't be an instance of the country class, it would be a string, and that assert would fail. Don't worry, do this, practice and do it in the practical exercise. And then I'm sure it will be quite clear, hopefully. Okay, so, right, how should we do this? So, okay, so I'm just going to walk you through the practical exercise. So, 3 setup stages basically. Install Miniconda with this line, with these 2 lines. So now they've integrated Mamba into Conda itself. Does that make sense to everybody? Everyone know what Mamba is versus Conda? They've integrated Mamba into Conda itself. So I haven't used it loads and loads, but I think hopefully it should be good. So we're going to try this. So basically, install miniconda, then you set libmember as the default solver for conda by just following these instructions. And then you do what you always have to do whenever you make a new conda install. You set the channel priorities like this. And then, I mean, you can just work in your base instance, or you can create yourself a new, you can just work in your base environment, or you can create yourself a new environment for this object-oriented session if you want to. And you can see whether or not I'll judge you for whether you use your base environment or not. Okay, so that's the setup, all quite straightforward. I'll share these slides with you somehow. I'll get everyone's email or something. And then that practical exercise itself, so this is practical exercise 1. So we'll just go through, this is going to take us, all the practical exercises are going to take us until like lunchtime tomorrow. So this is like the quickie to get started. So create a class of your choice. So I'm looking forward to seeing what kind of creative things you all come up with. So it could be superheroes, different kinds of dog, footballers, politicians, musicians, whatever you want. And give them some appropriate attributes. Whatever that might be for the particular class of your choice. Instantiate 3 to 4 different instances of that class that have different attributes on them. So basically, just like I was doing with scientists and Darwin and Dayhoff and all that. So this is just the basics, like get familiar with defining classes. The stretch goal, if you find that very easy and boring, have one of the attributes be instances of another class, for like the place of birth attribute with the scientists in the example code, and like code up an example that takes advantage of the objects having state, like updating the USA population in the example code. So I mean, you could also have as okay. So that's exercise 1 that we're going to do now. But I think we have time before lunch to get started. So do people need... Yeah. Okay, so let's go back upstairs and get started.